Hello team, Daniel, thank you and welcome to this session. I just want to share my screen so I can run us through how we are going to learn today. So the very first thing I want to show you is this script. Okay, so this is the script I'm going to use for us to learn together. Okay, so this script has everything we need. Second asset that I'm going to use for us today is this cheat sheet, which actually has everything we wanted to accomplish in terms of learning this code engine and the APIs and microservice with, really all the shortcuts here, right? So now before I actually walk us through right from beginning to the end, this live demo, let us understand some ground rules and why we are doing what we are trying to do. Okay, that's a quick overview, and then I will walk us through rest of the steps and live demo. So what we are trying to do today is basically run a serverless web application, a classic three-tier best practice architected web application using APIs and a code engine. That's on IBM Cloud, right? So that is the uh, goal we have today. Now, when we are talking about architecting a solution with this kind of approach, what exactly are the problems we are facing and why or how did we choose this particular approach to be the best fit? That's step number one or plan number one. So the business problems are pain points we are trying to address when we think about architecting our solutions like this. First and foremost, on a cloud, when you're developing on a cloud native solution that has to scale elastically with automation, normally the thing we think about is Kubernetes. We all know it is a framework. It gives you, it's like tires in a car, but it is not a car. So to actually use Kubernetes effectively and correctly is non-trivial, it's complex. The second thing is if you are trying to really architect a solution that is cloud native and elastic, you are actually have to do the whole lifting in terms of managing, scaling, writing the policies, making sure everything is secure, correctly done. What that means is it requires elevated skills. It also takes away your focus from the things you would like to do, that is basically domain knowledge and your own business skills, right? So that is the second thing. So if you look at the business real pain points, um, really these are the ones. The third one we are talking is cloud native. Cloud native is a lot of microservices, a lot of speed, lot of technologies coming together that are changing very fast. That means you have to be constantly keeping an eye on it with all the changes, skills, culture, speed, resources. Again, it's a distraction for many companies if that's not what your core focus is. So the developers are spending a lot of time researching and figuring it out and learning rather than doing what they want to do, which is innovation. So you can see these are the real pain points we are addressing right now. Now, how can we address or remediate some of these or all of these to the best of our ability? That's where Code Engine comes. IBM Code Engine is what I'm talking. Every other cloud vendor has something similar to this. Um, Basically, what Code Engine is doing is it's simplifying the consumer's experience. It could be end user, it could be developer, it could be administrator, it could be operator. But bottom line, whoever is using in whatever roles they are interacting, it's simplifying. It is also shifting the management and upkeep not from the end user or a consumer. Instead, in this case, IBM Cloud. So the whole 9 yards of patching, keeping it current, scaling, making sure security is hardened, all those things we're shifting away to IBM so we don't have to deal with that. We just have to focus on what our job is, which is innovation. It's a single platform that can also cater to different styles of programming models and deployment artifacts. For example, you have a three-tier architecture application, or you may have a serverless application, or you may have an event-driven application. So any of these or all these, you have an ability to deploy. Again, shifting the risk to some other vendor and uh, shifting a management to some other vendor so we can focus on our core competency. The other thing I want to tell you is while you are actually using this cloud platform where we're doing what we are focused on, you still are able to consume all other services that are on this cloud or any other cloud uh, absolutely easily, right? So that's seamless integration with IBM Cloud Services or other cloud services because pretty much every cloud has an API wrapper around it. And then the final point, very important, is you will not have to set up anything, either tooling, your runtimes, your SDKs, none of those, and you'll only pay for what you actually, when you use, for what actually you use. That's cloud consumption model. So that's why we care to focus on this capability. Now, if you look at the type of programming models I mentioned, it's a unified single platform where you can do all kinds of deployments. You can see the list here we have within this IBM Cloud Code Engine, right? So you can do event driven, you can do model view controller, traditional 3-tier or more than 3-tier. You can do cloud native with microservices and functions, function as a service. That's another thing we talk about. A source to image, basically a complete end-to-end containerization with automation, right? So you can do those kind of applications. You can do batch, you can do pipelining, you can do concurrent, everything to be managed by your provider, in this case, IBM. Okay, so the other topic I want to talk about is if all cloud vendors are offering the similar capabilities or equivalent capabilities, why should I care for IBM, especially Code Engine, because I can go to any other vendor, which I would submit you want to really take a closer look at IBM Code Engine because that's where IBM's differentiation comes. If you want to reap the benefits of open source technology, one of the hallmarks of all the clouds, um, with some exception from IBM, is the following. The actual cloud implementation by any cloud vendor is proprietary. But when you look at the technologies they use to host their capabilities, IBM's differentiation is it uses the most available open source technologies with most openness in the sense um, the APIs are available to everybody. There are no friction or no restrictions or no limits, and the APIs are published. And the underlying capabilities that are actually exposed to APIs, where possible, mostly are open source technologies. Now, why would we do that? If you do that, first, open source technologies and skills are open, available to everybody. So you have skills, books, capable engineers, a lot of pairs of eyes watching. Everything is easy to consume, right? Behind that open source founded technologies, IBM backbone is standing for you in terms of supporting and providing skills. So that is one thing, the first bullet. Um, you are actually avoiding learning proprietary technologies of all these cloud vendors and also getting logged into those and having to invest in those proprietary technologies that limit your choice. That's a second piece you can see here. Um, of course, this part is function as a service or what we call OpenWhisk or serverless. Usually you pay only when you run or consume your services. So that is common to all the other provider resources, but clearly that's one of the advantages for us also. And generally, when you look at cloud pricing, IBM is very competitive or um, or inexpensive. The other piece really I want to tell you is you're shifting the patching, the vulnerability scanning, the scaling, the security hardening, isolation, auditing, all kinds of upkeep for this platform on IBM. So you can focus on your own core competency. So that's actually the reason why we are discussing today this use case on IBM Cloud. Okay, I want to stop for a second here. We have any questions? If not, here is what the use case, how it might look. So the use case we have selected, which you all have access to, features the following highlights. Okay, the solution uses IBM Cloud Object Store service. It uses Cloudent database, which is nothing but CouchDB running on IBM Cloud with IBM enhanced capabilities, which I will discuss. Then you have our serverless compute called IBM Code Engine running on IBM Cloud with, again, IBM enhanced capabilities coming from open source. Then you have a classic three-tier architecture application with IBM Cloud Object Store using as a static website. Okay, so your solution has API, a presentation tier, and a backend tier, three tiers. Your web application front-end tier is written like this. It's MVC with a view. Your backend is Cloudent, and you have the glue that wires these two based on events, triggering the logic as soon as the front end puts out something or the backend reacts with the middle tier running as serverless. Okay, so that's actually is what a code engine microservice. And the application we are using is a well-known guest book application, which lot of serverless programming model showcases that as a good uh, best practice problem. Okay, that's what the use case is. What I'm going to show today is basically deploy a serverless end-to-end application on IBM Cloud. And the application is exposed as a REST service with, uh, API, and we have a cost packet. So this is the architecture you can see in a snapshot. You have a user coming through the public net in a browser. It can be any other way, but I'm going to demonstrate using a browser. Coming from a public outside enterprise, you have an IBM Cloud. We are using a web server with a static content being served using IBM Cloud Object Store. You have a get and a post, and you have the serverless microservice running on IBM Cloud on an elastic platform, and you have the backend. Okay. When I'm going to walk through, I'm going to, okay, so in the full disclosure, this example I have already deployed because the purpose of my demonstration is not to engage us in step-by-step how to do code. That's not the point. The point is what's in it for us as the solution is running, right? So this actual use case you all can deploy by yourself in this tutorial. The very first thing I'm going to show you, you can deploy this example yourself by following these 5 steps. And everything I'm actually showing you or explaining to you is equally or better explained right here. Okay, so that's number 1. Number 2, the source code for this is right here in this GitHub. Again, this is the beauty of everything open, frictionless. You can happily read, happily do this at zero cost to yourself on your own time. Only thing I'm showing you is just pointing to you where the resources are. The third thing I'm going to show you, the CouchDB, the cloud end that IBM is running on IBM Cloud is actually your freely available Apache CouchDB with IBM enhancements running on IBM Cloud with IBM support and backing. Okay, so that's the third thing I want to show you. Now I'm going to walk us through the whole solution here and explain to us um, what exactly are these components are. Okay, so let me close this. So you have seen it. Now I'm going to go here and start from beginning. It'll take probably about 10 minutes for us to get done. I'm just checking time for us, so I keep up on time. Yes. So I'm just logging in right now into IBM Cloud, which you all can open your own accounts. You can see this is my account. You can see this is my dashboard. Now I'm going to switch to my cheat sheet here and walk us through all components at the high level first. Okay. And the order in which I'm going to walk us through is, second here for some reason, in this specific order. So you will see what the solution has. The solution has some components, and each of the component that it features will have a number other than 0. So when you look at the complete solution resource list, I have a code engine, I have a storage resource, I have a database resource, I have 3 value added wire composition services that I'm consuming from IBM Cloud in this solution. Okay, so I have 1, 2, 3 plus 3, 6 resources. So back on our resource list, the very first one you can see is code engine. So I'm going to go to the first link here and double click. I have my code engine running. As I said, it takes 10 minutes for you to deploy this application with 0 cost, and you will end up here. So my goal is to walk us through first and explain in detail. So this is the code engine dashboard. Okay. The second thing I'm going to show you is the COS object, Cloud Object Store dashboard, or the landing page. Okay. It looks like this for when you build the solution. This is your Cloud Object Store. You have your static bucket deployed actually. When you click on the Cloud End, which is the third component of our solution here, the landing page for Cloud End looks like this. And you can drill down everything here, which I will do. The next thing I want to show you is the services that we have wired around this solution. And the first one of those services is activity tracker. This you would typically use for audit compliance. Okay, so all you do is just click and link and you have this capability, which I will walk us through. The dashboard for activity tracker, the cloud service, looks like this when you launch. Okay. The next service I'm going to show you is monitoring. An ability to monitor, keep an eye on your solution as to how it is functioning. The landing page for your monitoring service looks like this. Okay. And the dashboard for your monitoring service for our guest book solution when you launch looks like this in a completed solution, where you have an ability to actually look at how your resources are being consumed. For example, it might look like that. Okay, so I'm now going to the other pieces. This is your centralized logging. When you want to see how your components, it's again a microservice. Typically, you will have many other components in one complete unified solution, and each of them are running, scaling, operating on their own speed and their own pace and their own versions, right? So we need a centralized logging capability, connecting, correlating, especially when things don't work or fail. So that's where you have. And the dashboard for your log analysis looks like this when you craft your wiring completely. Now, The real interesting part is how would the solution look like for an end user when you completely deploy a serverless 3-tier application? It looks like this guestbook. And what I'm going to do to prove it to us, which I'm sure you already agree with me that we don't need to do proving, but let's do. So the guest book, all it does is basically it takes some basic information, and when you enter, it works. It's not a rocket science. We know it works because we have 4 entries already, and I just live demoed a 5th entry. Not a big deal. But that 5th entry that just happened, we can inspect correct working in a cloud and database on the back end right here. I entered the 5th entry right now in front of us. It made it to the back end right now, right? So that is the cloud database, the cloud and database that's running on IBM Cloud, which is IBM Enhanced CouchDB. Okay, so I showed you, we went through this tutorial link, we went through the GitHub link, went through the open source link. Now let's actually jump back to what I wanted to really talk about. So when we talk about code engine, okay, I want to actually explain the differentiating aspects of a code engine. When we mention a code engine, what we are talking is basically it is you within this you deploy key pieces of your business logic, nothing else, in any language that you love to use. You drop that capability as a function. That's all you do. You do just minimal business logic in a polyglot programming language of your choice. And you basically drop that into an instance of a cloud engine. Cloud engine is a container project. It creates for you a project, taking your code in the correct programming language with the correct SDK, with the correct version. If you write in Python, it'll use Python. If you write in Java, it'll use Java. If you use Rust, it'll take Rust library, matching your code. It will actually compiles, it builds the image, it containerizes that, it deploys that container. If it is a Docker, if it is a containerd, if it is a cryo, it doesn't matter. It containerizes. Now you have an immutable code. It pushes the code to a container, either public or a private registry. It sets up the runtime, as I mentioned. It injects the correct configurations. Remember, we are talking about declarative programming. When you want to change something in your logic, your goal is not to dive into the code and fix up or adjust it. That's not sustainable. Instead, you externalize as much as possible your code business, where you instead configure it through declarative human readable understanding, injecting environment variables or injecting other parameters dynamically, and then deploying, right? So you have environment configuration injected. You have source code Git, I mentioned. You deploy, you test, and you package it as a microservice. That is what Code Engine is doing for you. How do I know? I'll show you here. So that's your Code Engine. We have one application. We just wrote few lines of code. I will show you how many lines of code we wrote. So when you look at this guest book, it's telling you how many instances we have, what kind of CPU I'm using, how much of memory I'm using. It's a microservice. You can see 0.25 CPU, zero point 0.5 memory, very tiny footprint. And you can, when I select the actual instance, I can see the overview. I can see the configuration. I can see my runtime, showing you I have one instance minimum. I have max of 2 instances. I can change it to 100 in a heartbeat. I can also adjust my resources to higher RAM and higher CPU. I can also adjust any of these. This is elastic scaling. I have injected some configurable environment variables into my runtime with these declarations. If I want to point to a different version, by simply changing endpoint, I'm pointing to a different version, right? So, and I can also do dynamically last minute overrides. So that is actually is what the code engine is doing. Now, everything I'm showing you is actually containerized. How do I know? So if I go back to my original dashboard, I have one runtime, which I showed you. I'm showing you some other pieces here. You can see I have sensitive information and secrets and some things that are private, not to be shown to other people. I have made them, um, obscure, right? So you can see I have some of my secrets. I have my config maps. I have other things that are sensitive and delicate information not to be visible. They're all actually um, packaged into, sorry, I have to go back here, into my secrets, right? So these, if you look at the secrets and registry, there is a container registry running. The code got pushed to registry. You can see here, registry is there. I have built an image, have the bindings, have an events triggering. This is event triggered programming. This code engine is not running 24/7. When you actually enter another entry here, that's when this code engine comes to life. That's only when you will get to pay for the resources you are consumed. After that, it will go to sleep. So how is that magic happening? Events. As soon as the request comes in, that's an event. And how is the request coming in detected? When the browser pushes submits. That's where your web server is receiving in a bucket as a static server, right? So you can see all this stuff happening right here. Okay, so that's your code engine. Now, how can I know more details about code engine? Right here. This is our project. Everything I'm showing you can be done through CLI, through automation, or through APIs. We're doing through coincidentally by browser. And you can read everything about this right in the documentation link. Okay, that's code engine. Let's go to the second component. You get the picture here, right? So now I want to talk about cloud end. I may show you everything, but so when you are talking about a cloud end, it's a CouchDB with IBM enhancements running on IBM Cloud. What do you get as a customer benefit? First and foremost, it's a shared multi-tenant deployed solution. When you have a multi-tenant with completely isolated from one customer instance to another, you're actually getting cost savings because it's a shared resource. When you're using, someone is giving you a way of, way to. When you're not using those resources, someone else is using. So you get the better utilization. And what it means for end customers is uh, reduction in expense. It is regional scoped. What does it mean? A CouchDB on its own runs on one node. But when we deploy as a cloud ent on IBM Cloud, it is in that deployment, there is not a single point failure. That means it is deployed to 3 different data centers in one region. If you like, you can also deploy to multi-region, but generally within one geography, in whole region, you have 3 data centers. So you can have 2 data centers go down, you still will function with this cloud and backend running. The other piece I want to explain is when you store information in CouchDB, it's anybody can see it, clear text. But when you deploy and store your information in IBM Cloud Ent, it is actually encrypted at rest, and it is also encrypted in motion with SSL, right? So And how are we actually making sure the traffic on the wire is encrypted and only rightly authenticated people are using with identity access management wired for you automatically. Let's inspect that. So I don't have that ready access, so I'm going to go to this one, landing page, right? So you can see in my Cloud End database. First, let's look at this. It's in Washington, DC. I have two endpoints, public and private. I'm challenged by identity access management that IBM has that I have simply wired. I have a activity tracker enabled and it is encrypted at rest. And it is multi-tenant. It's a public cloud. Second thing I want to show you, it has authentication, as I mentioned, with IBM's identity access management. All the details are right here. Okay. If you're coming as a user, like interactive user like me now in a browser, or you're coming programmatically through API or a scripting, you will use this information. What kind of plan am I using right now? Different consumption model you can select. I'm using standard, you can use free, you can use even more elevated. So that's actually what I wanted to talk about. Now let's go back to my list here. Let's look at this piece, Cloud Object Store, because this is also a critical part of our solution here. So let me go to my class object right here. This Cloud Object Store, you can store information in this um, versioned object store, which is either structured, unstructured, semi-structured information. You have an ability to store across regions, across multiple data centers. Okay, so if you go to the landing page, it will explain to you all the details. Again, you have access management and everything. And if I go to my instance and my bucket, which is this one, I have an ability to look at my configuration. I have an ability to look at my permission. And I have my very complex, really highly talented code for the guest book, which let me show you how complex it is this simple. This is the piece you would write. And this piece is out there in the Git. The only change with a great difficulty you would make is this pointing URL. This is the only piece you'll change. Okay. And this also can be parameterized and injected, but um, so that is one thing I wanted to show. Now the configuration, if you look at in the COS object, Cloud Object Store service, you can get details, you can get endpoints, you can do versioning, you can do key management, activity tracking, monitoring, you can do rule-based lifecycle management, you have quotas, resource limits, retention. You can do all, you can see all this. One of the great things about this is ability to set up a website very quickly, easily with a static web hosting. And right here, one of the configuration parameters is this endpoint. And when I click on this endpoint, that's where we land up into your client. Okay, so that's your Cloud Object Store. Now let me go back to my rest of the, so at this point, this solution that I just have demonstrated has security built in. It is containerized. It has a pipeline. It's using other cloud services. It is driven by REST API with lightweight protocols, REST JSON, and web services. Uh, the permissionings are like this, ability to read, write, and manage. I have observability and monitoring. I have activity tracking for auditing. I have multi-tenancy with a virtual private cloud technology. That's a way I deployed. I have right now this example shows only a subset of these programming languages, but Code Engine can handle multiple languages, as I mentioned, and you can mix and match them happily. as microservices. It can support multiple container technologies and container registries, either public or private. I'm using IBM Private Container Registry right now, cloud-based. It supports event-driven programming, or it can do batch-driven, or it can do what we call massively scalable Kafka, right? So that's what I have demonstrated right now in this simple use case. And as you can see, the use case is not very complex, but the concepts in actually the use cases demonstrating are fairly non-trivial, right? I want to stop here for a second. I just have one more comment for those of you who are hardcore engineers. You want to know more gory details on what this use case or this script is showing you. They are right there at this link on public documentation, where IBM's code engine is actually running on IBM Cloud, architected to scale infinitely while also being managed as a multi-tenant deployment. So it runs on a managed Kubernetes platform. All parts of this solution are running on a Kubernetes platform. And that Kubernetes deployment is spanning one region with 3 data centers. Okay, so within a region, you still can have 2 data centers completely outaged and you can still function. And the management of this platform on which we are running our solution has shifted to IBM. You are not paying for it. You are not keeping it up with it. You are not doing a penny's work of it. IBM is doing. So that topology is explained right in this architecture, right when you click on this link in the public documentation. So the code engine runs on this architecture, and this architecture is nothing but it's a managed Kubernetes one region multi-data center deployment on which code engine runs. On top of code engine, you're deploying your solution. And that is why it is what it is. It's a multi-tenant, it is isolated, it scales to infinity horizontally, it is elastic. I think that's where I want to conclude right now. And I have just one request for our team here. This is frighteningly easy to connect and run and understand. And I would urge you to actually run this tutorial by yourself in your own time. Takes 10 minutes or less. And please connect the dots on this recording session and this script.
You'll post that link in the WebEx chat here so that everyone in attendance can see that as well, right?
Yes, absolutely. Brilliant idea, Roger. Let me find the chat here and right here I'm posting. Okay, so this tutorial which I'm showing you, which I posted in chat is right here. It has 3 steps. Fourth one is to deprovision, delete. You can do the whole 9, I mean all 4 steps in 11 minutes. 10 minutes to do this and 11th minute to delete. And it will cost you 0. Zilch. No cost. You can run this. And you can teach yourself and you can look at this documentation that explains why this is so compelling. Nothing proprietary here. All components are open source with IBM standing back for you. Team, any questions here? Anything I made unclear or any claims I made? You want to ask questions about our challenge? Please.
As of now, there's no questions in the chat, but feel free to still throw them in. as we will be doing a quiz. So,
Okay, at this point, back to you, Danielle and team. And Danielle, gratefully thank you.